Today we're going to look at applications of quadratics. When we do applications, it's in the context of word problems. So let's read through this. James has 600 feet of fencing to use to build a pen for his sheep and goats. The pen will be rectangular with a divider down the middle. What dimensions will give the maximum area of the pen? It does help to draw pictures. So if we think about it, if I have a pen that's rectangular with a divider down the middle, it's going to look something like this. James has 600 feet of fencing to use to build a pen for his sheep and goats. What dimensions will give the maximum area of the pen? Well, if we think about it, we're talking about two different things. 600 feet of fencing is going to give us a perimeter, but then we want to find the area. So in order to do that, we have to deal with our length and our width. Okay, I'm going to label my length and my width. 600 feet of fencing is talking about the perimeter, but we also have a divider down the middle. So when I do my length and width, I don't just have 2x plus 2y, I have 2x plus 3y because of that additional divider. That is my perimeter equation to get my 600 feet of fencing. I also need an area equation. Area for a rectangle is length times width, which in this case, it's x times y. All right, well, I have a system of equations. Because I want to maximize the area, I want to plug my perimeter equation into my area equation using substitution. So I'm going to solve for y and substitute in for y into my area equation. When I solve for y here, I get y equals negative 2/3 x plus 200. This is what I'm going to substitute into my area equation. So we substitute, so we get the area equals, in place of y, okay, we're going to distribute our x. And when we look at this equation, it's now looking like a quadratic. Okay, well, if we want to maximize something, think about it. The graph of a quadratic equation is a parabola. At what point on our parabola could we find the maximum value of our equation? The vertex. So we're going to use our formula to find the x-coordinate of our vertex, negative b over 2a. So negative 200 over 2 times our negative 2/3. Simplifying that, $150 is the x-coordinate of our vertex. But that's not the maximum area. How do we use this x-coordinate to find the maximum area? We plug it in to solve for y. So now y equals negative 2/3 times 150 plus 200. So y has a value of 100. The length of my pen is 150 feet, and the width is 100 feet to maximize our area of this pen. So we're applying what we've learned about our quadratic equations and the vertex of our parabola in order to find the maximum area for our pen. One more application problem. A hot dog vendor sells an average of 160 dogs each day for $1. He He wants to raise the price, but other vendors tell him that for every dime increase in price, he'll lose 5 customers. What should the new price be to maximize income? Okay, so we have our price, and we're talking about a number of hot dogs. They want to increase the price by a dime every day. So if you think about this, what should the new price be to maximize income? Again, we're talking about our vertex. So this is going to be our max point on our parabola. The coordinates are x, comma, I. I is going to stand for our income. Let's write our equations. The price. Well, the price of a hot dog is $1, but we're going to add a dime or more. We don't know how many 10-cent increases we're going to have, so X is going to stand for the number of dime increases. Now our number of hot dogs is going to change as well. We sell 160 each day, but that's going to decrease by 5 customers per dime increase. So that dime increase, no matter how many dime increases we use, is going to affect our price positively and our number of hot dogs sold negatively. Now, we need to talk about income. How do you find income for anything? Well, you multiply the price of the item times how many of those items are sold. So we have price times number of hot dogs. So in this case, we have multiplying our price and our number of hot dogs together. When I simplify this, I do have to FOIL it out. Let's make a note of that. FOIL. When we do that, we're going to get a quadratic equation. We want to write it in proper form and combine like terms. Now, here's my quadratic equation. We just said that the vertex is the maximum point on our parabola. So again, I need to find the x-coordinate of my vertex. Negative b over 2 times a is 11. But they don't want that. If we go back and look at what the question's asking, what should the new price be to maximize income? X was just the number of 10-cent increases. So our new price is going to be our $1 starting point plus 10 cents times 11 increases, which gives us a price of $2.10 to maximize our profit.